Okay, so this is going to be the first of a couple of entropy mini lectures, and I don't want to spend forever on them, but it's hard for me to lecture when I don't have people here to actually talk to. So I'm going to try to do these in areas where I think people might be confused. So I'm going to break this up into a couple of topics. I'm going to do on what the concept of entropy is. I'm going to do it on how to tell when you've got an increase of dispersion or disorder. I'm going to go over what a state function is. And so you can keep your delta S and delta H and delta G straight, and then do a couple of calculations from the problems in the NIMSY packets. So what is entropy? So entropy is, by definition, dispersion. When I was taking chemistry, my teacher would always was introduced to me as disorder, and that's a good way of thinking about it. It works about 95% of the time. Entropy is specifically talking about energy dispersion, and it's actually a mathematical concept or a probability in a way. And last year when I did this with you guys, when we talked about this briefly, I brought out a deck of cards and I played 52 pickup. And we talked about it in the sense that if you've got a stack of cards, like you do here, and you got the full stack, is it more likely that if you toss these up in the air, are they going to come back down in the pile together, or are they going to, go all over the place? And that's why it's fun to pick on little kids. You say, hey, you want to play 52 pickup, and then you throw them at them and go make them pick them up. You can do it even more simply. So I don't know if anybody here plays poker, but you always want to have a royal straight, or specifically a royal flush, which is your 10, jack, queen, king, and ace. So I've got that here. In my hand, I've got a 10 of clubs, a jack of diamonds, a queen of clubs, a king of hearts, and an ace of spades. So if you've played any cards, you know that there's 4 suits. And so if you knew that there are 4 tens, 4 jacks, 4 queens, 4 kings, and 4 aces, knowing that there's 20 cards and trying to guess them, your odds aren't very great. But if you narrow it down to saying, okay, you're going to know it's going to be, something in that royal flush, that would be great. So if I pulled out here the queen of clubs, you've got a decent chance now of being able to guess which card I'm going to pull out next, even if I'm pulling them out completely at random. And that works pretty well. Now, the odds still aren't in your favor because I've got 4 of them, but you've got a better chance. Well, what if instead of starting with 5 cards, I get rid of this, we won't pick on the queen, let's get rid of the 10. If I start with just 4 cards and I say, okay, I've got the king of hearts, I get rid of. Now you're going to guess which card am I going to turn up next. Well, now you've only got 3 cards to guess from. You've got a better chance at it. And that's kind of how entropy works, is that it's just running through all the mathematical possibilities of what could happen. So we apply that concept to chemistry. And it works with particles. It works with how things can get dispersed amongst your particles, and how those particles can disperse energy. So it's not always with how disordered things are, but all the different combinations those particles can be put together in. So we're going to get, in my next little video, talk about how you can start telling where you've got an increase in entropy. In this case, delta S has a positive sign. And when you've got an increase in order, which is less entropy, which is So if you've got more disorder, more dispersion, that's positive. If you've got less dispersion and it's more order, that's negative. It's less likely to happen, by the way. And how you can tell when those things are going to happen. So take a break, come right back. But wanted to get that concept hopefully a little bit cleared up for you.